Hello everyone, so welcome back to my channel, and this is my third video after I installed everything. I made my computer proper, and luckily I'm still continuing the streak. That's weird. I think something happened to me. uh, I generally don't continue anything that I start, but yeah, it feels good. Plus, I feel that there is not enough video about machine learning, deep learning in YouTube, so uh, friends of mine who want to learn, I mean friends or maybe juniors of mine who want to learn from YouTube, who are finding videos from YouTube, uh, they must get some content about all these things. And also I had to study a lot for understanding these things, so why not make a video on these things. So today I had an assignment in my college, so we are doing CIFAR-100 classification on dataset. So we will use CNN for this classification and classify all the images of CIFAR-100. So before that, before CIFAR-100, let me tell you something about images. So what we see image is like a beautiful 2D image, right? What we see, I'm talking about 2D images when I'm telling you about images. So what when we see that about images, I generally I'm speaking about 2D images, right? So what is image? So image is actually a 2D array where I should say where I mean it's a 2D array, and the array has values. So these values are later converted into colors, and we can see actually when you zoom an image too much, we can see pixels, right? Those pixels are the values of the arrays, right? So it's a matrix, it's a 2D matrix with values. Basically that's all. So when we say black and white image, so it's just a 2D array. Okay, so it's just a 2D array with 0 or 1 value. 0 represents black, and 0 represents white, and 1 represents black. When we say about a colored image, so there are three arrays. Okay, so it's not a two, so it's a 2D array, but it has three layers. So first layer is for red, second layer is for green, and the third layer is for blue. So I'm sorry, I think, yeah. So what is CIFAR-100 dataset? Let us first know about CIFAR-100 dataset. It has many pictures. It's a huge number of pictures, and these pictures are classified into 100 classes. CIFAR-10 is for 10 classes, but we will be doing CIFAR-100, this dataset. So this has 100 classes. So 100 classes, each class containing 600 images, right? So like classes may be beaver, dolphin, otter, sea, whale. These are all the classes. So first, what we will do in this video, we will learn how to put the dataset in our Jupyter notebook and how to read the dataset. First, we have to learn, before solving calculations, we have to know the numbers. Okay, how to visualize the numbers, how to visualize a dataset. So what we will do in this video, we will visualize the dataset, and how to extract the dataset, and finally extracting the images to arrays. This is what we will do in this whole video. So I took a lot of time in this introduction. Now I'm saying that after this, the video should be short because there's nothing much to do in this video. We'll do it fast. We came to this website where the CIFAR-100 dataset is available. I will put this link in my description. And now we came down, and we will doing CIFAR-100 dataset. So I think the CIFAR-100 dataset code will also work with CIFAR-10 dataset code. So if you want to try first with CIFAR-10, I don't think there will be much problem, because only the number of classes is less and the number of images is less. So I don't think there will be much problem. But yeah, okay, fine. We will do the CIFAR-100 because it's in our assignment, and we have to submit the assignment within 24th. Today is 17th. I don't know when I will upload the video, but I should upload it by 18th, I think, or I will try it today only. So we will go to this website, and we will download this version, CIFAR-100 Python version, right? So we will download this version. I am doing it in a file with CIFAR-100 and the sub file, that is dataset. I'll download this. It will take a little bit of time. It's 161 MB size. So till then, we will activate our uh, environment, right? So for that, we have to, okay, so anaconda prompt, we'll go to anaconda prompt, and then we will write conda activate tensor. We will do all our project in tensor GPU. tensor GPU. We can change it if we want to shift to PyTorch GPU. We can shift later, but now we will use tensor GPU and write Jupyter notebook. So where this environment came from, tensor GPU and PyTorch GPU, we have to for those we have to see my previous two videos. Not very long. Tensor GPU is 24 minutes, but if you don't see tensor GPU, you will not understand how PyTorch GPU is set up, because I downloaded CUDNN and CNN, sorry, CUDNN and CUDA in tensor GPU, and then I installed PyTorch GPU later on. So now I installed that dataset in, so it's taking a little bit of time. Anyways, we'll set our this notebook first. So I think it's in OneDrive desktop. I think it should be in projects CIFAR-100. Good. So now I will enter tensor GPU, using tensor GPU. Yep, our notebook is ready. We have to work on our data set. So it will need a little bit of time. So first what we will have to do, we have to come back to CIFAR-10 and copy this thing. This is already written about that, how to unpickle a file for a dictionary and all. So what we have to do, we have to copy this for getting the dictionary. In the file format is, the file format is not what our computer can read easily, so our notebook can read easily. So first we have to insert this function. So this function can read that file easily. So we have to insert this function first, then we have to insert the file. Oh, for the file, it's in zipped format, so we have to unzip it first. So we have to unzip it, and I'll extract it here only. So yep, it's extracted. Now I will copy all this, it's cut, and paste it here. Then I will delete all this too, right? Yeah. So we have our test, our train, and the meta is not required. So we need this to train our model, and this to find out our final accuracy of the model. So what we will do, we will put our file first. So file equal to R. So R is like, it will search for any file from the whole computer. So for that you just have to put the address there, copy, right, putting the address, and then I have to put right, train here, right? Yep. So yes, the file is accepted. Next we have to unpickle the file, right? Unpickle file, dataset is equal to unpickle file, right? So unpickled file is now in that dataset. So we have to first see what is how the dataset looks, right? Oh my god, yeah. So the dataset looks like this. So we have a lot of pictures here in the PNG format. Now I will see what is the type of dataset. So right, type dataset. So it's a dictionary. We can see that it's a dictionary. So we will see the length of the dataset. So when we see a length of a dictionary, we get the number of keys of the dictionary. We have keys in dictionary. Those who don't know, please study Python a little, because you have to clear the basics of Python first before coming to all this deep learning and all. So we have keys in the dictionary, and then so we can see that these are the keys. So to get the names of the keys, we have to write dataset dot keys. So this should give the key names, right? The file names, the batch level, the fine level, the course level, and what we are most interested in, the data, right? So this is the most interesting thing, the data. Okay, so what we will do, we will see the data. So we'll see what are the values under this B data file. Okay, so what we'll do, we'll copy it so that we don't have to write this every time. Data set. Okay, got it. So yeah, so under this key we have a array. So let me see the, sorry, dot shape. Let me see the shape of the uh, sorry, I think it's this, yeah. So the shape is 50,000 comma 3072. So 3072 is the shape of this array. It's a 2D array, so there are 50,000 1D arrays into 3072. So there are 50,000 images with each image having 3072 dimension. So there are totally 50,000 images. So, one thing we should say that 3072, we know that image is a 2D array, right? It's a something like, it should be something like something into something, but it's like it's coming 3072. So this is not acceptable. So what we have to do with 3072? So what we'll do, we'll pick up the first image. So to get the first image, we will write we will write, let's take the first image of the array. So this is the first image of the array, right? 25 into 25, 25 comma 25 comma 25. This is the first image. So what actually happens in this array? This is actually micro myro dot medium. So this is the, yeah. I will also paste the link of this image. So this array actually is like this. So I told you a color image consists of three arrays, like three levels of such 2D array, 2D matrix. So the first matrix, it's actually all the three matrices are taken and the values are written in a linear form. Like if 1 2 3 4 5 6, it's like this matrix, it's written, right, 1 2 3 4 5 6 7 8. So it's written in a linear form. The 2D matrix is changed into a linear matrix just by writing it next to next. So like this, this matrix is changed to this 2D matrix of three layers of matrix is changed into a 1D matrix, like this 1D array, I should say. So what we have to do, we have to reshape this 1D array to again a three level matrix, right? 2D matrix, and put all the three levels. Then we have to transpose this. Why have to transpose this? So for showing an image, we have to use matplotlib, right? Now matplotlib cannot show this shaped images. Okay, so it has to show 32. I mean, matplotlib only can show shape images of this shape. So these images, matplotlib cannot show such images, so we have to transpose this matrix and transpose this matrix to this matrix, and then we have to show it in matplotlib, and matplotlib can show that image easily. Actually, what's it? What's the actually matter? So matplotlib cannot show this three matrix. So there are three levels, right? It cannot show the three levels together. So what we will do, we will three colors in different levels, we cannot differentiate and put it together. So what we will do, we will put the three colors in one matrix, right? Like in one matrix, we are putting all these three colors. So it will be, matplotlib can process and then visualize the image. So what we will do, we will first, we have to reshape this image, reshape this array to a 2D matrix, right? So for reshaping, we have to do, first we have to take this as image. So what we will do, image is equal to, we will put this, yeah, we will assign a variable, and then what we will do, we will reshape this image to image is equal to, sorry, I'm really sorry, it's equal to image dot reshape uh, 3 32 32, right? So should reshape the image. Yeah, now the image is reshaped, so we can see the image, sorry, yeah. So now the image is like this is for the red, this is for the green, and this is for the blue, right? So it's like, now it's like this figure. So this is for the red, the first matrix, sorry, I think I should close this one. Yeah, so this is for the red, as shown as this this is for the green, this one, and this is for the blue. So we have reshaped the matrix from that linear array to this 2D matrix with 3 levels. Now what we have to do, we have to transpose this matrix, this one to this. So for transposing, we will again write image is equal to image dot transpose. What I have to do 1 2 0, right? So we will write 1 2 0. So we will transpose the image, and then what we will do, we will okay, first what we'll show, I will show the shape of that image. Okay, first I will show the image, then what will show the shape of the image. So now our image is like this. There are 32 arrays, 32 levels, actually 32 levels like this. There are 32 levels, and each level has a matrix of 32 into 3. So there are 3 numbers here and then 32. So the first column represents 25 25 25 195 200. This column represents red, this represents green, and this represents blue, right? So like this, again there will be 32 levels. So this is one level, this is the second level, this is the third level, and all, and this goes on. So now I'll show what, I will show the shape of the image dot shape, sorry. Yep. Yeah, so see, we can see this 32 32 3. So actually the levels, number of levels is shown first, so this 32 comes and then 32 into 3. So this type of shape is accepted by matplotlib, right? So what we will do, we will, okay, so we will import matplotlib dot pyplot as we will just assign a variable, so we don't have to write this whole thing again and again. So we will assign as plt, right? So now one thing is that when you write this, there might be some error, right? So the error is like that matplot is not available and so on, like something like that. So for that, what we have to do, we have to write a small line of code before, oh, I'm sorry, before it, that is exclamatory pip install matplotlib, this only, matplotlib, right? So you have to write this, then write this if matplotlib is not installed. Generally it's not installed when, if you have I did this previous time, and so I got the error and then I installed, and this time it's not showing the error. So run this run this whole cell together if error is showing, else you don't have to run if no error is showing. So I will actually sorry, yeah, so yeah, I import matplotlib, and then I will show the plot dot I'm show image, right? So it should show an image. So this looks like a cow. Yeah, it looks like a cow, and we can I did it for one image, we have to do it for every image. So what we will do, we will take the whole dataset and then reshape the whole dataset, then transpose the whole dataset. So we did it for the one image, so we can also do it for the whole dataset. So what we will do, right, we will assign a value. So what we will do, we did one thing earlier, that is we took a one image, right? This time we will not write this 0, this time we will only write till this, right? So we write till this, and then yeah, then we will reshape the whole dataset, the whole dataset. So we will use data dot reshape for reshaping the whole dataset. Actually, let's see the shape of this first. So data dot shape, so it's 50,000 comma 372, so 3072. So we have to reshape every images this part, right? So this is the number of, so we don't have to reshape this thing because this is the number of images. So what we will keep while reshaping, we have to keep the shape like 50,000 comma comma the thing that we did, comma we didn't show the shape after reshaping, but it should be like this: 3 comma 3 comma 2. So comma 3 comma 32 comma 32. So it should come like this. So why, okay, so why did we use 32 comma 3 comma 32 comma 32? So when we see this, yeah, when we see this, it's written here that every image is of color of size 32 comma 32. So we will use 32, that's why we use 32 comma 32. Plus we can see that this shape is 3072. This is only possible when we add up like this. So each matrix will be of 1024, so it comes 32 comma 32. So anyways, so we have to do it for the whole every 50,000 images. So what we will write, we will write data is equal to data dot reshape. Sorry, that's why I thought there is some problem. Data dot reshape dot. So we are mentioning the, I mean, in the dimensions. While mentioning the dimensions, what we will do, we can write 50,000 comma 3 comma 32 comma 32. But I will not write 50,000. I will write length of data, because I can show you that length of data should come 50,000. So I will write length of data, because let's generalize it. Let's not write 50,000. Let's generalize it. It's more cool, I should say. 3 comma 32 comma 32. Yeah. So we will do it together. So we will also transpose it together. Transpose. Let's transpose it like 0 comma 2 comma 3 comma 1, right? So what's 0 actually? 0 is I mean, this one represents 0, right? This one represents 2. 0, this one represents 1, this one represents 2, this one represents 0 1, this one represents 2, this one represents 3, right? So I'm transposing it like changing the dimensions to, again, I mean, it's like again reshaping it, but not exactly. It's like transposing, like just changing the dimensions. So when we transpose, we are writing 0 here. That means we are keeping the dimensions of the uh, first first value the same. Like it was 50,000, we are keeping the 50,000 here only. Then we are taking 2, that means 0 1 2, we are putting this 32 here. And then we are taking 3, that means we are putting this 32 here, and then we are taking 1, that means we are putting 3 here. That's why when we previously reshaped it, it's coming 32 comma 32 comma 3, because we didn't use this one, so it was like 2 comma 3 comma 1. Sorry, it's like 2 comma 3 comma 1, that comes 32 comma 32 comma 3. So we'll transpose it, and so it will reshaped and transpose whole together, so it won't, I mean, then we can see the shape of the, yeah. So it's 50,000 comma 32 comma 32 comma 3. It's I mean, it's a 32 comma 32 comma 3 matrix, but of 50,000 images. So for seeing the first image, what we will do, we will write this, right? So copy, yeah. So write data. For seeing the first image, we will write this, so it will show the first image. For seeing the second image, we can write this, so it will show the second image. What's this? I mean, it looks like a dinosaur to me. Like this is that dinosaur is having spikes behind. There's 2 legs and all. Oh, dinosaurs have 4 legs. Oh, dinosaurs have 2 legs and 2 hands, small. Okay, so yeah, an apple. So this goes on and on. So 3, it's a human being. Oh my god, there's some image here. I don't know whose, but yeah. 4, like, what's this? I mean, I have no clue. The pixels are, I mean, the image is so pixelated, like no one can have the clue, but CNN can distinguish. So that's the power. When humans fail, artificial intelligence, yeah, deep learning and all these things segregate those images. I don't know. This looks like a telephone. This looks like a telephone. So this is all. So we have the data here, and yeah. We can access all the images. So let's keep it till here, and we can access all the data. We can show the datas, and next we will classify all the datas. And yeah, next this is the first video. This is the end of the first video. In the next video, we will start our main part, that is building the CNN model and then classifying the model, and then we'll see how much our accuracy is and all. So that's it, and see you in the next video. Bye.
Please subscribe,